Myself, Aruna, working as assistant professor in S.A. Engineering College. Today I am here to discuss some gate questions related to stacks and heaps. What is the data structures? Data structures is a way of organizing the data in an efficient manner. This data structures is classified into primitive data structures and non-primitive data structures. These primitive data structures are the basic data types. And these non-primitive data structures is nothing but over that basic data types we can apply some operations and perform insertion, deletion, search, sort, like those operations can be applied over the basic data types. Here today we are planning to discuss about the list, and the list is nothing but a collection of data. The list is classified into linear data structures and non-linear data structures. Linear data structures is collection of data in a linear manner. Additionally, it follows a principle for stack, last in first out. For queue, it follows a principle called first in first out. Here in the non-linear data structures, the data are organized with the help of some relationship. For a graph, it maintains a vertex-edge relationship between the input data, and for trees, it maintains a parent-child relationship between the data. And today we will be focusing on stacks and trees. Before entering into the problem, let's have a brief introduction about what is a stack. Stack is a linear data structures. As I already said, it follows a principle called last in first out. Whatever the data you insert, it follows this principle only. So here you have you will be doing insertion, deletion. The technical name for insertion is push and technical name for deletion is pop. And here the top pointer is used to track where the data you have been inserted. If there is no element inside the stack, this top pointer will be pointing somewhere outside. So top will be -1. Here each row, whenever you insert, it will be indexed by 1. The count 1 will be updated. When you do the push operation, the top pointer will be incremented to 1. Whenever you do a deletion operation, that is pop operation, the top pointer will be decremented by 1. So as I already said, these three operations can be done in a stack. The push is nothing but insertion, pop is nothing but deletion, display means whatever the content is available inside the array, you can just display. So this is how your stack will be. First you will be inserting 10, then you will be inserting 45, then you will insert 12, 16, 35, 50 like this. Whenever you do insertion, the top pointer will be updated by 1. So how you can do the implementation? Implementation either using the array based implementation or linked list implementation can be done. Array based implementation in the sense you need to organize the stack, that is you need to predefine the size of the stack to do insertion or deletion. Here there are two exceptions. One is overflow and other one is underflow. Overflow means whenever you do insertion, the space should be available inside the stack. Then only you can do the insertion. If the space is not available, then that exception is called overflow. Underflow means when there is no data inside the stack and if you are trying to delete that data, it is not possible. So it is an underflow exception. So then what about this linked list? Linked list implementation is that always you cannot predict what will be the size of your stack. So in array based implementation, the first thing you need to decide what is the size of your stack, then only you can perform the operation. But in linked list, when there is a need, you can create a memory and you can do the operations. That is dynamically you can allocate the memory and whatever the size of the stack you can manipulate. So these are all the applications of stack: reversing a string, recursion handling, parenthesis handling, expression conversion, evaluation of postfix expression, backtracking, number conversion. These are all the applications of stack. So let's discuss few questions related to stacks. So look at this example. Consider the following sequence. Like this, a sequence will be given and the inputs also will be given. As I already said, push is nothing but insertion, pop is nothing but deletion. So at the end, after performing this operation, what will be the value of S? So we will try. So the first input is push 54. 54 means what? You need to check what is whether the stack is empty or full. Initially there is no elements inside the stack. So you can directly insert 54 here. So what will happen to a top will be pointing to this element after insertion. Then push 52, push means insertion, 52 need to be inserted here. The next is pop. For pop, you should not give any elements as an input. Whatever the topmost element is there, it will be deleted automatically. So 52 will be deleted. Then the next input is, next operation is push 55. 55 means you need to insert the data 55 here. Then push 62. 62, the spaces should be there, then only you can perform insertion. So the finally what will be at the top? 62. So that is the answer for this question. So the value of S here is 62. Now next this is the second question we will discuss about here. These are all the operations they will be given, and additionally here in this question what they have asked in the sense, they need to ask, you have to find out what is the sequence of popped out values. Popped out means deletion order you need to find. So again you need to do some certain calculation to find the order. Push 1. Push 1 means the first you need to push the data 1 inside. Then the next input is 2. Push 2. Insertion. Then pop. Pop means deletion. Which element you are going to delete? 2 you are going to delete. So this is the first output. Then after deleting, this data will be deleted. Then what operation you are going to perform? Push 1. So put it inside the stack. So next operation is push 2. Put it inside the stack. Next what you are going to perform? Pop. Pop means the topmost element will be deleted. So this order you need to find. The next pop is this element will be deleted. So next pop operation, this element will be deleted. So next what is there? Push 2. So you need to insert the element 2 inside the stack. So 2 will be inserted. Then you need to perform a pop operation. So the final answer will be 2 2 1 1 2. This is the sequence of popped output value. This is how you need to find. You need to insert, and then what order you need to read the question carefully. In the question they have asked what is the order for deletion. So this is how you need to track your answer. Now we will discuss the next question. Now next application is expression conversion. Given an infix, what is an infix? Infix is nothing but it is an expression which is of this format. So in the input you will be having operands and operators. So the general syntax is operand followed by operator, and any operand you can have. 2 operands followed by 1 operator. This is a simple expression. So for this expression, what is a prefix? Prefix means the operator should come front, operand 1, operand 2. So what is the syntax here? Operator followed by operand 1, operand 2. Then how can you find the postfix expression? Postfix expression answer is, for this expression, the first operand, second operand followed by operator. So what is the syntax? Operand 1, operand 2, operator. So this is the basics knowledge you need to know about the expression conversion. Then these are all the expressions given possible questions. You can find the answers in a simple way. So these are all the steps you need to follow. Initially when you are starting your problem, your stack should be empty, and the output once you completed your problem, the stack should be empty. And scan each and every infix from left to right. You need to scan from left to right, and operand, if there is only 2 possibilities of inputs available, one is operand, other one is operator. If it is operand, you need to write it in the output. If it is operator, you need to do some calculations internally. I will explain you next. And then if there is other possibilities, open and close parenthesis in your problem. So if you find a open parenthesis, you need to put it inside the stack. If you find a close parenthesis, until where is the open parenthesis, its respective pair, whatever the elements inside in between that open and close parenthesis, you need to pop one by one. At the end, at one point of view, you will be reaching the end of your input. When you reach the end of the input, whatever elements inside the stack, you need to pop everything one by one. So let's discuss some problems. Here this is the expression given. So let's solve this problem. So before that I will be telling for operator, to handle an operator you are having three cases. First case, equal preference. Equal preference, when the equal preference operator, for example plus and minus, plus multiplication division, both are equal priority operators. In this scenario, when the inside the stack you have a division and outside the stack you have a multiplication, the conclusion is you need to pop the element, pop the operator which is inside the stack, and you need to put the new operator inside the stack. This is the first case. Second case, you have a high priority operator outside and you have a low priority operator inside the stack. In this scenario, you can, the final output, you can put that particular operator inside the stack directly. And in third case, you are having a low priority operator as an input, and inside the stack you have a high priority operator. In this scenario, whatever operator available inside the stack, you need to take it outside and then you need to push the new low priority operator inside the stack like this. So your final output will be like this. Okay, now we solve this expression. So this is a infix expression since the operands and operators are available like this. So what is the first input is an alphabet. So you can write it in the output directly. What is the second one? What is the second input? It is a plus symbol. Then next input is B. You can write it in the output directly. What is the next input? It is the asterisk. So which case this belongs to? This belongs to this case. So inside the stack you have a low priority, outside the stack you have a high priority operator. So what will be the conclusion? You can put it inside directly like this. Plus asterisk. So then open bracket, you can put it inside the stack just like that. Then next input string is C. You can write it in the output. Next one is plus. You can put it inside the bracket stack. Then the next input is D. You can write it in the output. Next, once you encounter the close parenthesis, so whatever the values available inside the stack till this open parenthesis, you need to pop it outside. So what is there? Up to from the close parenthesis to open parenthesis, in between how many ever operators available, you need to write it out. So here in our case we have only one operator, so we will pop it out. So this one will be popped out. Now your stack will be like this, plus asterisk alone. Now what is the next symbol? Divide symbol. So when the divide symbol comes, divide and multiplications are equal priority. When equal priority scenario arises, you need to pick the element which is, you need to pop the element which is inside the stack and you need to put it in the outside. So the answer will be like plus new operator you need to put. Then what is the next operator? Next input is F. You need to write it here. What is the next symbol? Plus. Plus symbol already inside your stack you have a high priority, so you need to take it outside. Slash you need to take outside. Now plus. See, again you have a equal priority. When equal priority, one of the operator need to be taken out. Your stack will be now like this. Plus symbol is there. The next input is D. Again already you have the symbol D. If D comes, no issues, you can write just like that. Then the next symbol is asterisk. Asterisk means already low priority is there, you can write it on the top. The next symbol is E. So you can write it here. Now I have reached the end of my input string. So now what I can do? At the end of the problem, this one should become empty. So I need to pop all the elements outside. Pop the first operator asterisk and pop the next operator plus. So this will be the final answer. So see here ABC plus asterisk minus F slash plus DE. This answer will suit my problem. So postfix evaluation. Evaluation in the sense the values in the previous examples here for operands directly they have given the operands, you are not evaluating. For this operands you are just converting into another expression. But here evaluation means you need to, the values for ABC will be given, you need to find the single result. See this example. This is a postfix expression, that is for A, it is like A, B, C. For each operand they have given directly the values. You need to find the solution for this. Here the simple thing, if it is an operand, that is if it is a number, you need to put it inside the stack. If it is an operator, you need to pop two elements from the stack. You need to perform the operation and you need to put back the result inside the stack. Okay. So we will solve this one. So say what is the first input? First input is 10. So we can put it inside the stack. What is the next input? It is a 5. We can put it inside the stack. What is the next input? Plus. When you find a operator, you need to perform the operation and whatever the result you get, you need to put it back inside the stack. So this will be here and this one should be here. So 10 plus 5, the answer is 15. So your stack will be having the value 15. What is the next number? 60. Put it inside the stack. What is the next input? 6. Put it inside the stack. What is the next one? Divide. So divide. What is the first one? 6. 60. 60 by 6 you will get the result as 10. Then what is the next input? Multiplication. So write multiplication symbol. Take this one, put here 15. So 150. Then what is the next input? It is 8. You need to put it inside the stack. Next one minus. Minus is an operator. You need to perform the operation and you need to put back the result inside the stack. So this one 8. So 150 minus 8. So what is the answer? 142 will be your answer. In the options you need to select 142. So 142 you need to put it inside the stack. Now we have reached the end of the input. So this is the final answer. Like this you need to solve. Another way is that they will give you a function like this. For this function you need to compute, you need to find the value of this function f of s. Okay, the input sequence will be given 2 minus 3, 2 minus 1, 2. These are all the inputs. We will be using it as I. And then s is the thing we need to, f of s we need to find. So let us work out this problem. So initially in the problem they are given as f of 0 is equal to 0. Like this they have given. We are going to start. What is this? Is the input sequence they have given. 2 minus 3, 2 minus 1, 2. So start from here. Push 2. What is the first input? We need to do the insertion. Push 2. So f of s we are going to find. This is the formula they have given. Maximum of f of 0 comma, that is f of s. Initially we need to start with f of 0 comma 2 plus what is I value? I value is nothing but the input, that is 2. So maximum of 0 comma 0 is 0. 0 plus 2, the answer is 2. Now the f of s is 2. Next input, you take the next input minus 3. Push minus 3. Again compute this function. So maximum of 2 comma 0, 2 is nothing but from here you have got f of s. That is 2 comma 0 minus I value is 3. So you will arrive at the answer -1. Again the next input, for the next input do the push operation, compute the formula, you will be arriving at the answer 2. And the next input is -1. -1, what is the previous f of s value? 2, 2 comma 0 minus 1, that is equal to 1. So next input is 2, push 2. In push 2 again apply here maximum of 1 comma 0 plus 2, that is equal to 1 plus 2. You will arriving at the answer 3. Check the this one, it is available in the C. Check in the choice, it is available in the choice 3. So like this more questions will be available in stats. Next we discuss about binary heap tree. It is a non-linear data structures. Very simple. This is but the thing is you need to understand the problem. If you understand the problem only you can solve it easily. Before entering into the heap, first you should know about what is a binary tree. Binary tree means a node should have a maximum of 2 children. So you need to always filling the data from left to right. You need not check any other conditions. Just like that you can fill the data. Now I will be constructing a binary tree. Then I will give you a demo how to solve heap and max heap. So for this binary tree, first node, first input is 10. Whatever input is available in the first, that is the first input, that is the root node. Then you need to start filling the data left, right. So binary means 2. Maximum a node can have 2 children. One is the left, another one is the right. So the second input is 20. Then pick the third input. You need not check any conditions here. Just to fill the data left, right, left, right, left, right, like that. The next input is 40. Write 40 here. Next input is 50. Write 50 here. Next input is 60. Like this you can construct. Maximum to minimum 1 or 0. Okay. So this is a binary tree. Here you can have a max heap or min heap. Max heap means the root should have a maximum value when compared to the child. So for the same tree, let's construct a max heap. First insert the root element. The first element is a root element. Insert. Do the insertion 20. When you do the insertion, you need to compare it with the parent. Okay, but here in our case the parent is a small value, so you need to swap these two. 20 will come here, 10 will come here. Next you need to insert the next element 30. This is max heap. Max heap means what? The parent should have maximum value when compared to the child. Next element is 30. When you insert here, again you need to follow binary heap property. Along with binary heap, you need to follow this max heap property. That is, the parent should have maximum value. So when compared to 30, 20, you need to compare the newly inserted data. You need to compare with the parent node. So when you compare, this is minimal, so this will come here. Just swapping only. So your final tree 30, 10, 20. This is how your tree. Then furthermore 40 will be inserted here. Then when you insert 40, it need to be compared with its parent. It is a minimal. Again in the new location you need to compare with its parent. So 40 will be moved here, 30 will be moved here. Like this you need to keep on constructing the data. Okay. Then how to do the deletion? Deletion means in max heap we will be deleting the root node only. When you delete a root node, what will happen? The entire tree will left as a orphan. So what you need to do means you need to replace some values there. Which value will replace? In the sense the data which is at the lowest level, that is recently entered data, will be replacing there. So we will be replaced. Once 40 is deleted, the last node is for 10. 10 will be replaced there. After replacing, what you need to do? You need to check whether the max heap property is preserved or not. Check when compared to 10, 30 and 20 is greater value. Out of these, 30 is greater. So this is a deletion. This is insertion. This is deletion. Okay, clear? So this is max heap. Mini heap means means the same thing, the root should have a minimal value when compared to the child nodes. If not, if the rule is getting violated, you need to do the swap operations. Okay. With this we will go for problems. The same thing is given here. The root node must be the greatest value among the keys present. Look at this tree. In some cases they will give you the tree and ask you to find which is the max heap here. Out of the 4 options, you need to select the correct one. First you need to check whether all the trees are binary tree. Then you compare with the root node. Which when the root node is satisfied, check with its root node. That is the grandparent node. And then check with the level by level you need to check. Okay. So next one is mean heap. Mean heap is, as I already said, the parent will be having a minimal value when compared to the child nodes. If not, you need to do the swap operations. The same thing what I have said just before. So these are all the steps. Now we discuss the questions. Look at this. A max heap is given, and for this max heap you need to find multiple max heaps are given. You need to find which is the correct answer. So observe before solving the problem. Observe which is the wrong one here. So binary tree means always we need to fill from left to right. So all the values when compared to this, all the levels should be completely filled. So in this scenario, this tree here, you don't have any data here. So surely this is not a binary tree. So remove this option. Then go ahead with this option. Check. When compared to 2, 6 is greater. When compared to 6, 10 is greater. So this is correct. This side it is correct. And then compared to this one, 5 and 4, this is greater. And compared to 8, this is greater. So obviously this will be the correct answer. Okay, like this only you need to find. So B is the right answer. So what are all the necessary conditions for a tree to be a heap? The tree should be a completely a binary tree, and every node, every root is greater or smaller than the child value. Greater means it will be a max heap, smaller means it is a min heap. So both these options are correct. So this will be the answer. So here in this example you need to find the values will be given. You need to find which is the max heap among here. You need to construct the max heap. So we will solve this one. So what is the first input? Look at these inputs. We need to construct a max heap. We need to find 32. The next input, keep filling from left to right. The next input is 15. After inserting 15, check with its parent. The rule is not violated. Then check with the next element 20. Again check with its parent. Rule is not violated. The next element is 30. Left, right. Again move to the next level. Start filling from left, right. So 30 you will be inserting here. When compared to 30, 15 is a minimal value. So swap these two. 30 will come here, 15 will come here to the new position, and check this also. This is no, you need not to swap here. It is already in the correct position. Then the next element is 12. This is the place you need to insert. The next element is 25. You insert here. After inserting, check with its parent. The rule is violating here. So you need to swap. What is the next element? 16. Solve it here. So the final one is 32, 30, 32, 30, 25, 15, 12, 20, 16. So this is the answer. 32, 30, 25, 15, 12, 20, 16. So this option is correct. You need to solve it manually, then only you can find out which is the exact answer. So this is the solution. A is the answer. So this is the next question. Here you need to, this is the tree given, values given. You need to find in which order you are going to have the values. So for this again you need to construct the tree. Again you need to construct the tree. After doing the insertion, you need to insert 2 more elements and you need to write it in an array. So construct the tree. 10, the next input is 8, fill it left side. The next input is 5, fill it here. While filling, you need to ensure the property is not violated. Okay, the next element is 3, insert it here. Its parent is greater, so no issue. So insert the next element here. And the next element is 1, insert it here. And the next element is 7, insert it here. And here the rule is violated, swap these two. So 7 will come here and 5 will come here. Okay. So after constructing the tree, write from the for the answers, you need to write level wise. Write the first level, second level and third level. The answer will be 10. The next level 8. Next one 8, 7, 3, 2, 1, 5. So this is the right answer. 10, 8, 7, 3. This is the right answer. Okay, after constructing the tree, write the answer in sequence. So consider a heap tree. This is a heap tree. You need to, after insertion, the same like that. You need to construct a heap tree. After insertion, what will be the answer for your heap? The answer you need to write. So we will construct. The first input is 40. The next input is 30. The next input is 20. Next input is 10. You need to also ensure whether it is a max heap or min heap. You need to ensure. This is a max heap, so no need to worry. So parent should have a maximum value. So far there is no violations. Then the next input is 15. Insert it here. Next input is 16. Next input is 17. Next one 8. Next input is 4. And then the next input, after constructing this heap, you need to insert a new value 35. Where you will insert? This is the next place to insert. So insert 35 here. After inserting, check the property. But its root is having a lower value. Since it is a max heap, this should have a greater value. So swap these two. After fixing it into the new location, ensure whether that location is correct for that. Check with its parent. No. So again 35 will come here, 30 will come here. So the answer is 40, 35, 20, 10, 30, 16. Just write level wise. You will arrive at this answer. So given a binary max heap, the elements are sorted. This is the order they have given. And you need to delete 2 deletions you need to do. So you construct a binary tree, that is a heap. You construct a binary heap, max heap for, check the question, it is a max heap. After constructing the max heap, you need to perform deletion operation. Remember, deletion means always you need to delete the root element. After deleting the root element, you need to replace the root with the recently inserted element which is available at the lower level. So 25, next input is 14, next input is 16, the next input is 13, next input is 10, next one is 8, 12. Okay. So whenever you do insertions, the same thing. The rule should not be violated. The root should have the greater value since it is a max heap. Check whether you need to perform deletion operation. As I already said, the maximum element will be available in the root. When you delete the root node, you need to replace it with this value, the last value. So after inserting this value, you need to ensure which is the data, whether this tree is max heap, whether it is not violating any rule or not. Check with these two children, note 14 and 16. Out of this 16 is a greater value, so swap it here. 12, 16. So check with its children's 8, only 8 is there. So no issues, 8 is at a minimal value and compared to 12. So we can have this as it is. Then you need to, one deletion is completed. Again you need to perform the second deletion. When you perform the deletion, 16 will be deleted. That is, your tree is now like this. 16, 14, 12, 13, 10, 8. This is the tree you are having. After deletion of one node, 25, your tree is like this. Now you need to perform again one deletion. So delete this element. After deletion, as I already said, you need to replace it with the lower level, the last entered data, that is 8 will be replaced there. So after insertion, you need to check whether its property is preserved or not. 14, 12. Out of these two, which is greater? Obviously 14 is greater. So we need to replace 14 here. 14, 8. 14, 8, 12. You need to draw the circle, that then only it is called as tree. Just like that, if you write a numbers, it is not a tree. Then 13, 10. So the final output you need to write, you need to check with this, the 8 is converted here, you need to check 8 with 13. 13 will go here, 8 will come here. Okay? Then anywhere else the rule is violated? No. The final answer is 14, 13, 12, 8, 10. Got it? Here is the option. So with this, hope you can understand the stacks and heaps. If you have any doubts, we can have more sessions like this. So we'll discuss all the problems. Thank you all.